So now notice we again have exponential equations, but this time we will not be able to write both sides as the same base. Notice in part A, 5 to the x equals 7, it's not going to be easy to write 7 as a base of 5. So in that case, what we have to do is we have to use logarithms. So from the definition of the log, x equals b to the y implies y equals log base b of x. So if you recall the definition of a logarithm, this was an if and only if statement. But in these 4 problems, we're going to go from left to right. We have something that's exponential. We're going to write it as a logarithm. So in part A, one way you can solve this is by using your definitional logarithm at the top there. If 5 to the x equals 7, we're going to write it as a logarithm. Remember, the base of the log is the base of the exponent. The base of the exponent in part A is 5, so we have log base 5. Log base 5 of what? Of 7 equals x. So notice again, 5 to the x equals 7. Sometimes students like to do that little swirly thing. Totally fine. Well, notice x is solved for, so this one's done. Another way you can solve for it is you can take the logarithm of both sides. A log is an operation. Just like adding, subtracting, square rooting, whatever you do to one side, you have to do to the other. You can take an log log, you can take a natural log, you can take any type of log you want. If I took just a log, a log base 10 to both sides. Then notice on the left-hand side, since I have an exponent for my argument, according to the power rule, I can bring that exponent in front and multiply. This is a linear equation. You have x times the log of 5 equals the log of 7. So you're multiplying x by a number, which happens to be the log of 5. It's not a pretty number, but that's okay. So how do you undo multiplication? You divide. So we'll say x equals log of 7 over log of 5. 2 comments. 1, even though they look different, these are the same answer based on the change of base rule. 2, be careful, this does not equal the log of 7/5. This guy is a quotient rule. And as I just said, this was a change of base rule. Do not get those two confused. Students like to get those confused. Well, they don't like to, but they do get them confused because they see the division bar and they go nuts. Don't get nuts. Okay. So as far as using the definition, or as far as taking the log of both sides, totally up to you. Sometimes the definition won't work and you will have to take the log. Not to say it won't work, it's just going to be a lot harder. But for all these problems, definition is going to work just fine. So in part B, same as part A, we cannot write them as the same base. 6 is a multiple of 2, but not a power of 2. So since we can't write them as the same base easily, we're going to use logarithms. What's the base of the exponent? What's the base of the log going to be? Hopefully for both cases you said 2. Log base 2 of 6 equals 2x plus 1. Log base 2 of 6 is a number, so treat it like a number. This is a linear equation. To solve for x, we work outside in. We're going to subtract 1, and then what? Hopefully you said divide by 2. So here I am subtracting 1, and then I'm going to divide by 2. Can I subtract the 6 and the 1 here? Nope, because the 6 is with the logarithm. It's just like if we had square root of 6 minus 1 over 2. Can I subtract the 6 and the 1? Nope, because the 6 is with the square root. So since it's part of that function there, it's what you're taking the log of, you can't subtract them. So your final answer is the gorgeous log base 2 of 6 minus 1, all divided by 2. C and D are related. To do C and D, and to use this property, notice the exponential term has to be all by itself first, meaning no coefficient except for 1, nothing being subtracted or added to it. So in part C, notice we're subtracting 3 from the exponential term. We have to undo that. How do we undo that before we write this as a log? We add 3 to both sides. So we have e to the 5x equals 11. So now we're ready to write it as a log. What's the base of the exponent? Hopefully you said e. Since the base of the exponent is e, that makes the base of the log e. Well, what type of log is that? That's a natural log. Natural log of 11 equals 5x. Notice we don't write the e. It's implied thanks to our friend, the natural log. Great. To solve for x, you are multiplying x by 5, so to undo that, you're going to divide by 5. And notice x is already by itself there, so we stop. So in part D, what do we have to do first? We have to divide by 7. Can I multiply the 7 and the 2 together, by the way? Nope, because the 2 is being raised to a power. So order of operations says exponents before multiplication. So I have to get rid of that 7 first by dividing by it. So now this looks like part B there. Base of the exponent is 2, so the base of the logarithm will be 2. Log base 2 of 9/7 equals 3x plus 4. This is another linear equation. Solving for x, working outside in, we're going to first subtract 4, and then what are we going to do next? Hopefully you said divide by 3. And x is all by itself. So these are all exact answers here. Notice we don't have one decimal on the screen. So leave it alone as log base 2 of 9/7 minus 4, all divided by 3.